Good morning, dear friends. So today we start this fifth experiment of second term, section A, that is inorganic chemistry, part first, that is volumetric analysis. So in this analysis we have different experiment. So here we start this first experiment, that is estimation of sodium carbonate and sodium hydrogen carbonate present in mixture. So this is our fifth experiment in this second sem of FYBSc. What is the aim? Estimation of sodium carbonate and sodium hydrogen carbonate. It is, we also known it as a sodium bicarbonate. Chemical required are HCl 0.05 normal, the solution of Na2CO3, that is sodium carbonate, sodium bicarbonate. So this solution is given by teachers. So we give this solution to you in volumetric flask, 100 ml volumetric flask. This phenolphthalein indicator is required, methyl orange indicator. So this is the double indicator titration. Apparatus is volumetric flask, beaker, conical flask, burette stand, etc. So what is the theory behind this experiment? For such analysis, double indicator method is generally used. We call it as a double titration. As this mixture contains two different alkali, that is sodium carbonate and sodium bicarbonate. The titration involved neutralization of two bases using suitable indicator at two different pH value. See, when this mixture sodium carbonate and bicarbonate is titrated with standard HCl solution, this phenolphthalein endpoint correspond to partial neutralization of sodium carbonate to bicarbonate. See, when this sodium carbonate react with HCl, so this reaction gives formation of sodium bicarbonate and NaCl. So it is a partial neutralization. This determines the base on selective use of indicator. Both sodium carbonate and sodium bicarbonate react with HCl. The process depends upon the fact that when sodium carbonate react with acid, the reaction takes place in one stage. On one stage only, whereas this neutralization of sodium bicarbonate takes place in two stages. See, this sodium carbonate react with HCl to form bicarbonate, just now here we mention here, and the sodium bicarbonate in second step react with HCl to form a salt and water. But when we have only sodium bicarbonate, it react in one step to neutralize this base. This phenolphthalein can be used as indicator only up to bicarbonate stage. Thus, if a mixture of bicarbonate and sodium bicarbonate, sodium carbonate and sodium bicarbonate is titrated against standard HCl with phenolphthalein indicator, it will indicate completion of reaction. Then methyl orange is used as an indicator and same mixture is titrated against the acid, then it will denote the completion of titration. It is clear in the next part. What is the procedure? See, burette 1 filled with HCl solution, standard HCl solution. We teacher in laboratory, we supply this alkali mixture to you in a 100 ml volumetric flask. So this is a given mixture of bicarbonate and sodium carbonate in a 100 ml volumetric flask. Dilute this solution up to the 100 ml by using distilled water and make this whole solution in beaker and stir it for homogeneous. Fill the burette 2 with a dilute solution of alkali mixture. So this diluted solution, now its volume is 100 ml, diluted 100 ml volume of alkali. That solution is filled in burette number 2. Take 10 ml of diluted solution from burette 2 in conical flask. Add phenolphthalein indicator 2-3 drops. The solution become pink. So this basic solution shows pink color due to phenolphthalein indicator. Then titrate this pink color solution with HCl, which is filled in burette number 1 till pink color just disappear. And at that time, that burette reading, this is the end point of first indicator, that is pink to colorless. This is the end point of first indicator, that is phenolphthalein indicator, and we record this burette reading as a V1 ml. So this is our first reading, V1 ml. In the same decolorized solution, we do not discard that solution. In the same volumetric flask, colorless volumetric flask showing colorless solution, in that same solution we add 2-3 drops of methyl orange indicator, that is the second indicator. Now this solution become yellow in color. Continue the addition of HCl from burette 1 with stirring. What is the end point? This end point is yellow color, it changes to orange red. And at that time this burette reading shown, we record it as a V2 ml. So this is the one titration. We get V1 and V2 reading in the same volumetric flask by using same burette. We do not fill burette again. See dear student, here we do not fill burette again. We fill burette once, we add indicator twice in the same volumetric flask, and we get the 2 reading in the same volumetric flask. So repeat this process 3 times, this step 4 to 10, and find out this amount of given alkali is present in that given solution. So this process we repeat 3 times, so we get the 3 readings of V1, 3 readings of V2. See this observation table. So first observation table, this phenolphthalein indicator is used, endpoint is pink to colorless. At that time we record reading as a V1 ml. So first reading V1 ml, second reading V1 ml, third reading V1 ml. 3 times we repeat this process, and at that time we take a mean to get a V1. In second titration we use methyl orange indicator in same flask, endpoint is yellow to orange. We continue the titration, and then we get a reading as a V2 ml, second V2 ml and third V2 ml. We take its mean, that is a constant burette reading. We take this mean and we record this final V2 ml of reading. Then we go for this calculation. So difference in reading with 2 indicator, that is V2 minus V1, is a XML. This is the difference. For half neutralization of sodium bicarbonate in 10 ml solution, this 0.05 normal HCl requires V2 minus V1 ml. V2 is a final reading, V1 is a first reading. That difference gives the half neutralization of Na2CO3. For complete neutralization of Na2CO3, we multiply this by 2. This reading, this difference is multiplied by 2, we get a complete neutralization. For neutralization of sodium bicarbonate, this HCl required is V2 minus this half neutralization part. See, this is the half neutralization of Na2CO3. So that part must be subtract from V1 reading, and we get the 2, that when we open this bracket, multiply, we open this bracket, at that time this V2 become negative, this V1 become minus minus plus. So this V1 plus V1, that is 2V1 minus V2, and this is the complete neutralization of NaHCO3. So take this calculation for calculate the amount of Na2CO3. For 100 ml 1 normal HCl solution, it neutralizes 52 gram of Na2CO3. So here 2V2 ml 0.05 normal HCl gives 2V2 into 0.05 normal into 53 divided by 1000 into 1. When we solve this, we put this reading V2 and we solve, we get the X gram of Na2CO3. But this X gram is 10 ml diluted solution. See dear student, we provide you a solution in 100 ml volumetric flask, and from this 100 ml volumetric flask, after dilution we take out 10 ml for titration. So this 10 ml titration gives X gram of Na2CO3, but we provide that whole solution that we have to dilute to 10 times. So for whole solution, that is total 100 ml diluted solution, this X into 10, it gives the total amount of Na2CO3 present. So whatever be the answer here, that is only for 10 ml solution which is used in titration. For whole 100 ml solution, we multiply this X by 10 and we get the final answer as a whatever may be the answer, that is the grams of sodium carbonate. For calculation of sodium bicarbonate, same 100 ml 1 normal HCl gives 84 gram of NaHCO, so that is the molecular weight. This is the V2 minus V1 ml of 0.05 normal HCl gives V2 minus V1 into 0.05 normal into 84, that is the molecular weight of NaHCO3, divided by 1000 into 1. When we put this value V2, that is final reading, minus V1, that is initial reading, difference we multiplied by divide however 1000, we get the answer, that is Y. So this Y gram of sodium bicarbonate is obtained, which is obtained from 10 ml solution, 10 ml diluted solution used for titration, but our whole solution is 100 ml. So for whole 100 ml solution we multiply Y by 10. At that time, what is the answer in gram? That is the whole amount of NaCO3 present in given solution, given or provided solution. So finally we have this result table. We write this V1 is a titrated reading by using first indicator, that is phenolphthalein. This titration reading with methyl orange indicator, that is V2 ml, we note it here. Amount of sodium carbonate in given solution, that is 10x for given solution, that is 10x value. Amount of sodium bicarbonate in a given solution, it is a 10y, we write here in grams. So in this way we find out this amount of sodium bicarbonate and sodium carbonate present in given solution. Thank you dear friends. You should write this experiment as experiment number 5 in your notebook. Thank you.